to renewable energy on Modern Marvelous. Tucked among the rolling hills of central New York is the Fenner Wind Project, owned by Enel North America. Though not the world's biggest wind power project, it represents the new thinking in wind energy. Bigger, smarter, and fewer wind turbines, eliminating the need for dozens of smaller turbines. Fenner is composed of 20 wind turbines built and maintained by GE Energy. Each stands 215 feet tall, has a rotor 218 feet in diameter, a bit longer than the wingspan of a 747, and produces 1.5 megawatts of electricity.
When you look at the average New York household, this wind power project can actually power about 14,000 homes over the course of a year.
Converting wind to electricity begins as the wind flows over the rotor's airfoil-shaped blades. The combination of lift and drag causes the blades to rotate.
There's a tremendous amount of kinetic energy in the wind, and similar to sailing or lifting an aircraft off the ground, the wind blade captures that kinetic energy and provides lift. And that lift, like a propeller, is converted into torque.
That tremendous torque is put to work inside the turbine's power plant, 200 feet above the ground.
The blades collect the energy from the wind and convert that energy from wind energy to mechanical energy, transmits it through the main shaft into the gearbox, which the gearbox steps it up from about 1 revolution to 70 revolutions and puts it on the output shaft of the gearbox, going into the generator here, which then produces power. The generator operates between about 850 to 1,400 RPMs.
From the generator, the electric current travels down the tower to underground transmission lines and into the power grid. The main challenge for wind power is the fact that the wind is not blowing at all sites, at all times. The solution is to diversify the locations of wind turbines and guide the turbines to the wind. Computer controls can turn the entire turbine up to 360 degrees to catch the prevailing wind. These controls also direct individual blades to pitch into optimum wind position.
Each axis can operate independently of each other. All the blades pitch to the same degree that they're told to pitch to and maintain that. Each turbine will come online on its own. It doesn't need any human interface to do it.
Technicians are needed to perform maintenance on the turbine and to change a light bulb on occasion. Those with a fear of heights need not apply.
I have the benefit of having probably the best office window in Madison County. I mean, if you look out the top, it's absolutely gorgeous up here.
Clusters of wind turbines are often called a wind farm. And in the case of Fenner, New York, it really is a farm. The land is owned by local farmers like Donna Griffin. For landowners, going green is a good way to make some green.
We have a lease with them where they pay on the production of each turbine. It's just another crop that we harvest. It's much easier than harvesting our other crops. The wind is free. As long as the turbine is turning, we know we're going to get paid.
From New York to North Dakota, American farmlands and badlands are turning into wind-swept power plants.
The United States has some of the best wind resources in the world. Just to calibrate you, North and South Dakota theoretically have enough wind to power the whole country. The challenge is tapping that and transmission and distribution. But if you look at the center of the country, the wind resources are tremendous. If you look at the coastlines, the wind resources are tremendous.
Farming and wind power have a long history together. In fact, it was on the farm that wind power saw most of its advances. The famous Dutch tower mills, introduced about 1390, saw many innovations over the centuries, including leading-edge airfoil sections on its light wooden blades, which dramatically improved the art of aerodynamic lift. These pre-industrial dynamos were mainly used for drainage and grinding grain into flour. In the late 19th and early 20th centuries, small windmills on American farms were the first to employ a large number of light, efficient steel blades, which produced significant torque, even in low winds. Some of these machines were also the first to convert wind to electricity.
In the last century, we had a lot of wind power installed in the California West to power water pumps for agriculture and for cattle. And so we actually started a lot of this country with alternative energy. It was mainstream then, but they dropped off the radar screen as the prices of oil and fossil fuel became so inexpensive.
The new era of wind technology began in the early 1980s, when Zond Systems began putting 50-kilowatt wind turbines, tiny by today's standards, in the hills of Tehachapi, California.
During the 1980s, we went from 50, 60 kilowatts to a couple hundred kilowatts by the end of the decade. During the 1990s, it was 550 kilowatts, and then we went to 750, and then by the end of the decade, we were at 1.5 megawatts.
The company also implemented variable speed turbines, which allowed the rotors to accelerate and generate additional energy during a violent gust of wind. Advances such as these, along with smarter computer controls and lighter, cheaper, and more aerodynamic rotor designs, have made the cost of wind-powered electricity competitive with that of natural gas and even coal. Wind power is experiencing exponential growth. Several European nations will soon be getting 20% or more of their electricity through wind. In June of 2006, the U.S. Department of Energy announced it would also aim for a target of 20%. Right now, the figure stands at less than 1%. As engineers continue to make wind turbines more resilient and cost-efficient, you can expect them to get even bigger. As always, the bigger the rotor, the more energy that can be captured. Some of the biggest turbines are reaping the massive wind harvest on the oceans.
There are ideas on the board for bigger turbines in excess of 5 megawatts, 6 megawatts to go offshore, out in the ocean. We see many technical opportunities to continue to push wind technology even beyond where we've pushed it today. We are making progress. We are the future. We are reducing our dependence upon oil, and we're trying to save the environment at the same time. It's a plus.
This is a viable technology. It's economic. It's proven. You know, what more do we need to know?
Wind is certainly a hot technology. But so is this. Geothermal energy. Hot enough to power a small nation. China, second to the U.S. in total wind potential, plans to produce 30 gigawatts of wind power by 2020, enough to power between 13 and 30 million Chinese households. Renewable energy will return on Modern Marvel.